Okay, so in this video I'm going to look at Theorem 12, and again I'm going to look at doing it under these four headings: given, to prove, construction, and proof. Now Theorem 12 just says that if we have a triangle ABC and if a line L is parallel to BC and cuts AB in the ratio S is to T, then it also cuts AC in the same ratio. So let's have a look at that. Now, what we're given here is a triangle, A, B, and C, and we have a line XY that's parallel to BC. So XY is parallel to BC here. And AB is cut in the ratio S is to T. So there are S units here and T units down to here. So what do we want to prove then? Let's just write that out. So to prove, we want to prove that AY is to YC is also cut in the ratio S is to T. So this line here has cut AB in the ratio S is to T. S is to T here. We want to prove that this line here has also cut AY in the same ratio, S is to T here. So let's have a look at construction next. What are we going to do here? So let's have a look at construction. I'll just do that in blue again. So let's see, construction. Okay, so what we're going to do here is divide AX. So we're going to divide this section here into, so we're going to divide AX into S equal parts. And we're then going to divide XB. We're going to divide XB into T equal parts. Through each point of division, we're going to draw a line parallel to BC. So through each point of division, we're going to draw a line parallel to BC. Okay, so let's do that then. We're going to divide AX into S equal parts, and we're going to say, let's say we'll do it like this. There's 1, 2, we'll do 3 here, and each of these lines then is parallel to BC. We're going to divide XY into T equal parts, so we'll just draw a line across here like this. We'll do 3 as well, 3 lines. So we've divided AX into S equal parts, and we've divided XB into T equal parts, and we've drawn lines parallel to BC across here. Now let's just move on to the proof then. How are we going to prove this? So the proof, right, so now according to our previous theorem, so according to Theorem 11, the previous video that I did, the parallel lines, all these parallel lines here, the parallel lines cut off equal segments along AC. So what does that mean? What we did here was we cut off equal segments down along here from A to X and equal segments from X to B. But according to Theorem 11, because we've drawn parallel lines along here, these lines also cut off equal segments along AY and YC. So if we say we're going to let K here. So I'm going to say one of these segments here is the length K. So let's take this length here, and we're going to say that length there, we'll call it K. Okay, so each of these segments here is length K. Okay, so that means then that the length AY is just going to be equal to S times K, and the length YC is going to be T times K. Why is that? Well, if one of these lengths is K, we know that we had S number of these. We divided AX into S number of divisions. So because we drew parallel lines across here, we know we're going to have S number of K's here. From A to Y, there's going to be S number of K's. So the distance from A to Y is going to be SK. And now we divided XB into T equal segments, and because we drew parallel lines across here, we also have T number of segments here. So we're going to have the distance between Y and C as T times K. Now, if we take the ratios then of AY is to YC, we take the ratio of AY is to YC, that's just going to be exactly the same as SK is to TK. So the ratio of this to this would be just equal to the right hand side's ratios, if you like, SK to TK. And we can see here that AY then to YC is just going to be S is to T. The K's here will just cancel out. You can divide across here by K if you like. And this is exactly what we wanted to prove.